I am Hiten Harish Sonar from Government College of Engineering and Research outside Khurd, Pune, presenting the project named Microwave Oven. Is my internship project with provided by emertxe Information Technology on embedded system, and I am here to glad to present this microwave oven project in front of you. In this whole 1.5 month of internship training, I had learned most of the topics during this internship. First of all, that was introduction to C language, conditional loops, and operators, arrays, and pointers, functions, and string storage classes, introduction to the embedded systems and microcontrollers, microwave oven project, MPLAB IDE, C8, Big PixSim introduction to various peripherals of PIC16 F877A, which microcontroller we had used in our project, and interfacing various peripherals of PIC16 F877A, multiple quizzes taken by emertxe Information Technology. Next slide is content. What I'm going to cover in this full video. The contents are basically what is embedded system. It's the first and the basic question. What is the embedded system? Second one is what is microwave oven? How it works and how should we have to encode it? Okay. Then the requirements we need for this requirements, the needed IDEs, some microcontrollers, some softwares. Okay. Next one, what is PixSim Lab? Where we are performing virtually. These are what is PixSim Lab. Next one is CLCD. What is CLCD? Character liquid crystal display, which is basically used in everywhere in the world. Next one is matrix keypad. What is matrix keypad? Say it to be. Next one is ISR, interrupt source routing. Uh, After that, we are going to see timer. After that, project implementation demo. Okay. So the next slide contains embedded system basics. What is embedded system? Embedded system is not but a combination of a hardware and software and a real-time operating system where we are running on. Uh, Second one, it is a microcontroller based controller system used to perform a specific task of operations. The requirements of embedded system are much not more than we know about that microcontroller, and we have a basic knowledge of embedded C or any embedded language, embedded C++, embedded Python. Challenges in embedded systems are those which we have to know about everything of that microcontroller, which we have to program. We have to develop some header files too for that program. Different trends in embedded systems are where we are seeing in this era. uh, Home automation is basically everywhere. It is a trending topic, and it's a good example of embedded domain. Okay. Next one, what is microwave oven? So micro oven is used to heat food using electromagnetic waves, which we know very well. Essentially, every microwave includes a component called the magnetron, and it's the basic component of every micro oven. Okay, this magnetron is an oscillating device that creates electrons which are heated up and sent into the microwave cavity where they heat up ingredients. There are various modes in microwave, but basically we are going to focus on four main modes such as micro mode, grill mode, convection mode, start mode. After some time, we are going to see what these all means. So first of all, we will have a look to the block diagram where we have to proceed and how we have to do our work. Okay, so first of all, we have to integrate fan, buzzer, matrix keypad, and display with microcontroller. fan is to cool down the temperature after the heating is done. A display, CLCD display we are going to use, which will show modes, time, and temperature of the micro oven where it is. Okay, matrix keypad is will be we are going to use for knowing or inserting the time in seconds or minutes or the temperature or selecting modes by pressing 1, 2, 3, 4, and we are going to use a 3 cross 4 matrix keypad in this project. So here are the some modes which we are talking about. First is micro mode. Micro mode, this mode is used to cook food in traditional manner. The maximum power of it is 900 watt. In traditional manner, we've seen that we burn a gas and cook a food at the flame or at the temperature of that gas. Okay, in that manner too, this micro mode works. Next one is grill mode. This mode is used to cook meat and bread. User can set time according to his convenience. Okay, meat and bread needs more energy, needs more power, needs more heat to cook faster. Next one is convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes up to 1 minute to preheat, 1 to 3 minutes to preheat the oven. User can set time accordingly. It's all about us, how much time it takes to be preheated. Okay, so I had used 1 minute to preheat the oven, but we can set up to 3 minutes or as per your wish. So basically, what are the requirements for this project? So you have to be a knowledge on embedded C, and in this internship, our first week was based on the embedded C language, where we have learned very basic things like variables and more, like starting from variable constants, pointers, and strings, many more. Oh, okay. So and next thing is MPLAB ID, means every for performing any embedded or any of the program, we have IDE. So for this project, we are using MPLAB IDE XC8 compiler, which compiles the code and give us and show us where we are going wrong side or the right side, and that is. Next one is Pixim Lab, where we are going to have our virtual conversation with that hardware. Next one is CRCD, character liquid crystal display, where we are showing or displaying all our project. Next, matrix keypad. Next one is interrupt source routing. Okay, so first of all, we are going to see what is under the Pixim Lab. In Pixim Lab, there is one controller, Pix16F877A. So there are many controllers, but we are using this Pix16F877A, which is interfered with RS232 LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, analog to digital converter, LM35 temperature sensor, I2C, RTC, EEPROM memory, GPIO pins, and many more things. Basically, we are using buzzer, ADC, temperature sensor, matrix keypad, CLCD, and fan type things. Okay. So first of all, here is CLCD. CLCD is character liquid crystal display. In Pixel Lab, there are two types of display: 16 cross 2 display, 16 cross 4 display. In 16 cross 2, there are 16 columns and 2 rows where we have to display, and the second one is 16 cross 4 display, where it has 16 columns and 4 rows to display. It displays the ASCII character and some special characters too. It is most commonly used display in our world. We say two types of communication modes. It has 4-bit mode and 8-bit mode. Basically, we are using 8-bit mode. Next one is matrix keypad. Here for the example, I had shown 4 cross 4, but Basically, we are using a 3 cross 4 matrix keypad. This is a keypad in which number of tactile switches are connected in row and column concept, and this is used when more number of user inputs are required and still want to save some controller input output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. It's totally based on us how we are going to use that. Next one, interrupts. Interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Basically, interrupt is not any complicated thing. It is simple as when we are running a program and interrupts the that interrupts the code to execute the another part of the code, and after the execution of that part, it returns on that code on the previous code and continue from that. It requests to microprocessor or microcontroller unit to stop the processing, and then after execution of the interrupt source routine ISR functions, ISR files, then after that our main file get executed earlier. Then the MP or MCU acknowledges the request and attends to the request, goes back the processing where it was got interrupted. Polling. It is a process where the controlling device waits for an external device to check the readiness or state, often with low-level hardware. Next one is ISR, Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an interrupt. An ISR means when interrupt interrupts the code, then a part ISR, Interrupt Service Routine, ISR function get executed. ISR file get executed. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction retire. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enables, places the addresses of from the program counter on the stack, and return from interrupt. Okay, next one is timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Time counter is a software designed to count the time intervals between the events. Resolution, which is also called a register width, 8 or 16 byte, etc. Tick is preferred as the change from one number to the another number. It may be up count or down count. Quantum, which depends on the system clock setting in a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. Maybe it is 1:1, 1:8, 1:4, or 4:1. It depends on which scaling we are using, pre-scaling or post-scaling. So project output should be in four manners. First, we discussed micro mode, grid mode, convention mode, and start mode. Okay. One by one, we are going to see them. Let's have view towards our project demo. First of all, this is the file where micro oven project file where we had inserted a header files naming clcd.h, main.h, matrix keypad.h, micro oven.h, and timers.h. Okay. After that, we source files like clcd.c, isr.c, where we have to interrupt that and interrupt the main function, main source file, and execute this ISR file. This is the main.c where we are going to have a switch case operational flags, naming we are using case switch case statements, power on screen, menu screen, display time, dual mode, convention mode, and many more. Matrix keypad.c. This is one of the uh, matrix keypad source file which we had done one by one. Microoven.c where we are going to have the displays after the completion of temperature or many things. Okay, after that timers.c, where we are using timers cmr2 on t out ps3 equals to 0. These are uh, the indications got from that. So we are going to implement our project powering on microwave oven. This is the first screen. Second, micro mode, grill mode, convention mode, start mode. Okay, first we are going to the micro mode, showing power equals to 900 watt. Set time, we are aiming to have a 10-second time. After entering that, we got 10 seconds. For pausing, we had used 5. For reason, we use 4. After this completion, a message is popped up that time up, enjoy your meal. And we got to the display, first screen of the display. Second one is grill mode, where we can set up time in second. We can clear this by using star and enter by using hash. So we use 6 second, enter, and the time starts. And as the time stops, it shows time up, enjoy your meal. Third one is convention mode. In convention mode, we have to set the temperature. It's let us set it to the 125 degrees Celsius and enter it to after that preheating occurs. It is has said that up to 1 minute, and we can change as per our requirement. And for 1 minute, it shows count reverse counting from 60 second to the 0 second. Now preheating is done as per the basis of our requirements or our execution we have provided. Okay, 30 seconds are remaining. So we are using a HD 44780 16 cross 4 display, LCD display, heater, cooler, and this is the temperature inbuilt in this Pixim lab. Okay, 10 seconds are remaining. After this, we have to save the time. It's preheating. Okay. After that, we have to set the time for how much time we should have to wait. And this is the timer. Enjoy your meal. Fourth one is the start mode, and I hadn't discussed anything about the start mode. In the start mode, by using 4, 5, 6, by using 4, we can add more 30 seconds to this start mode, to this temperature increasement and the speed of fan. It all depends of the code. We can pause it by using 5, start it by using 4, and stop it by using 6. And that's all from my side. Thank you to the emertxe information technology for providing me such beautiful internship. Thank you all.